Good morning, everyone, and welcome.
Good morning, sir.
Yes, পারাবি কিছু বললা?
Sir, good morning, sir.
Oh, আচ্ছা, ঠিক আছে. Good morning. Welcome back to the class of 3201. I think yesterday we were talking about the challenges in representing geographic phenomena. And this was the slide we discussed. We have only one more slide of the challenges. These are the multiple attributes of geographic phenomena. So if there is a geographic phenomena, for example, if there is a building, can you just say that, I mean, you can say it's just a building, but then when we are using land use map, and then so we were doing land use map based on the buildings at the building level, right? So we have maps of all buildings of Dhaka city, and now we want to identify for which purpose this building is being used. Okay, and we create some categories. For example, we say business, we say residential, we say factories or industry, or we could say, for example, shops. So shops also falls into business. Okay, then we could say government offices, we could say private farms, etc., etc. So when you make these classes, and then when you try to map a building, when you try to add one attribute to that building, you will realize that many buildings has mixed uses. I mean, most of the buildings has mixed uses. At the ground floor, you might find an outlet of a super shop. That could be Agora, that could be Shopno, that could be anything. Okay, then from the first floor or from the second floor, you might find that it's being used as school. So that's education, right? So from, let's say, so Shopno or Agora, whatever that is, that uses the ground floor and the first floor, and from the second floor till the, let's say, fourth floor, it's being used as school. That could be school for the kids, that could be school for the primary school, and maybe a little bit of high school as well. So after that, the rest is being used as offices. That could happen. So there could be multiple companies, multiple farms that have offices in that building, or the rest might be being used as residential purpose. Okay, so you see, in one building now we have a business, that's a super shop. Then we have education, that's the school. Then we have farms. We can also categorize them as business, although sometimes they might not be business as well. So that is offices. Okay, I think it's better we call them offices. And then we have residential purpose as well. So we have 4 types of activities going on in a single building. So it's not really possible to just tag it with a single tag. Okay, it's not really that possible. So why? Because it has multiple attributes. So it's very common in the natural phenomenon as well. So there are that's why it says the potential number of attributes is vast, and it also depends on the perspective. If you're looking from the physical perspective, then you might find a potential you might find an attribute. If you're looking from the societal perspective, you might find another attribute for that entity. If you're looking from economic perspective, now you can include any economic activities or values. For example, you can say GDP, you can say the economic status, condition, etc., etc. If you're talking about demography, now you could say that what is the demographic condition of that building or of that entity. You could say there are these many households present in that building, and in each household we have this much of age groups are living, etc., 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 male, female, and so on. Okay. If we think of the environmental perspective, we can add so many things. What is the waste being produced from that building? How are we treating that waste? Okay, and how much of energy that building is using or consuming, the residents or the users or the people who are staying in that building, how much of energy are they using? Okay, so all these things are now being part of environmental. So when you think like this, then you have so many attributes that you can include. So how do we overcome this this challenge? Well, when we take data or when we record data, what we do is we only focus on the single thing that we are doing. For example, you want to find out how much waste are they producing, because you are interested in waste management. So you go to that specific location, and what you find out is exactly about all the information about the waste and nothing else. Okay, so also another example could be you might be interested in how much waste is there any relationship between the waste production or waste generation and then socioeconomic condition. So for example, maybe if someone is economically weak or struggling, they might not be producing as much as waste as whereas the well-offs are producing, because well-offs, they do not really care about things. So when they're having some fruit, they want to just have the flesh of the fruit, nothing else. Okay, and maybe when they want to have some they have so many options to eat. I'm just talking about from the food perspective. They can have Kit Kat, they can have cakes, they can have snacks, they can have fruits. On the other hand, those who are economically struggling, maybe they are only having rice and curry, something else. Okay, they do not have that much of food options. So if you think from that perspective, then the organic waste that every family is producing, you might find that those who are well off, they are generating more waste. Both organic and inorganic, plastics and other things as well. Okay, so they are generating more waste compared to those who are economically struggling. And if you want to find out that relationship, okay, you want to find out, is there any relationship? If there is, then how strong is the relationship between the waste generation and the economic or societal status? So what do you do is you go to these places, you go to these buildings, you go to every household, and you try to find out what's their average income, how many person in that family is earning person, and how much waste weekly or daily do they produce. Okay, all this information. So at that moment, you are really living out all the physical aspect. You are really living out all the other aspects, like what is the purpose of these buildings? That is the land use aspect. Okay, you are leaving all these informations out. You are not thinking about all this information. So that's how we try to overcome this challenge. Okay. However, if you want to map out, if you want to represent geographic phenomena, do remember that there are almost infinite potential to represent. Okay. So that's what it says. The more closely we look at the world, the more detail it reveals. So potentially ad infinitum. Potentially you can reach the infinity. Okay. The more you look into the details, the more details you will find. The more details you will find to map out. So you cannot do that. We humans, we maybe cannot do that. Okay, so that means in a way, if you can do it, then you will be creating a virtual world inside your computer, whereas the living world that you are living in has a replica in your computer. Okay. Anyway, so now that was the basic idea, the theory behind raster, vector, and the maps and representation. So now we will look into the software aspect and the application aspect as well. After looking into the software and application aspect, then we will move back into the theory again, and we will talk about coordinates and how do we connect these representation and then the software. Okay, so the bridge between these two is the coordinate information, not coordination, sorry. So one of the popular software or the major software that we have in GIS, the commercial one, is the ArcGIS. And why do I discuss ArcGIS instead of QGIS here? That's there is a reason behind it. The reason is since ArcGIS is it's a commercial software, that means there are customer supports. So anytime you face any problem with the software, you can always contact the customer support, and the customer support will be trying to help you to solve that problem because that's their job, that's their product. On the other hand, QGIS is free of cost, so there is not really any customer support. However, there are forums. So what you can do is you can join in that forum. You can ask people that I'm having such problem. How can I solve this problem? Or what to do? Is it a bug or something? So there are developers of QGIS as well in those forums. They will leave you some comments, or they might they might tell you what to do. How can you overcome that problem? So that's not anyone's job to tell you how to solve that problem. I mean, no one is getting paid, so it's of their will. If they wish to tell you how can you solve that problem, they will. If they don't, they won't. As a result, the response that you get from the QGIS might be slow. The response that you get from QGIS might be a wrong one. Okay, so that's why you will find in future that although QGIS is getting very, very powerful over the time, and it's a competitor of ArcGIS. However, in many offices they still prefer ArcGIS. Okay, because of the customer service and the stability of it. There is another reason behind it. That reason is ArcGIS is sort of a legacy of GIS software. So it was the software that it was the fully functioning software that we have, and it's the software which is being used in the universities for teaching students. And these students, they are graduating and then going to the job field, and they prefer ArcGIS because they were trained in that software, so they prefer it over the QGIS or other GIS software. And then they become the policymakers, and when they're making the policy or when they're buying the softwares, they prefer ArcGIS again. So it's a chain reaction. You see, I was also trained in ArcGIS, using ArcGIS. So wherever I go, I prefer ArcGIS because I know the software, I know the interface, I know how does it function. I know if I get into a problem, how to solve that problem. Okay, whereas it comes to DIVA GIS or Quantum GIS or QGIS, I'm not really that familiar with that software. However, I know the theory, so I can anytime I can learn that software, I can utilize that software. But why should I? Why should I waste my time to learning another software when I have already quite some skill on one software? So that is the logic of many personnel who are using GIS softwares. Okay, so that's why whenever you will be out in the field, you might encounter ArcGIS more than QGIS. However, saying that at this time, many are preferring QGIS. That is also true. So what we will do is I will try to touch both software, QGIS and ArcGIS. But for now, I want to focus on ArcGIS only because that's the commercial one. Most people use it. If you go to US, the US government uses ArcGIS software. Okay, so if you go to the different department offices, you will find they are using ArcGIS. If you go to USGS, you will find they are using ArcGIS. Same is for Bangladesh. If you go to different agencies, departments, they are using ArcGIS. So we will focus on this. Then we also touch on the QGIS part. So it's a product of Esri. It's the most widely used GIS software worldwide. So it was originally developed around vector models. However, over the time, it started incorporating raster models as well. And the legacy series includes the ArcInfo. So we started with ArcInfo, then improved to the ArcView, then ArcIMS, ArcSD, ArcEditor, and so on. And now we have ArcGIS Pro. I mean, along with ArcGIS 10.8, we have ArcGIS Pro, I think 2 point something. We also have ArcGIS Online. And you will find that previously, even 5 years ago, Esri was producing only the software which was focusing on ArcGIS desktop version, which is we have with us. However, in last few years, Esri has produced so many other different softwares as well, which are cloud-based. For example, ArcGIS Pro is to some degree, it's cloud-based. You can store your data on the cloud. You can access your data from the cloud and work on your software. All you have, and also your licensing would be from the cloud. So that's why there is no cracked version of ArcGIS Pro, because you do not create any license on your desktop. Okay, you have to connect to the Esri server, connected to the Esri server to get the license activated. So there are ArcGIS Online as well. In ArcGIS Online, you do not really have to have anything. You go online and you do the analysis online, just like Google Earth Engine. Okay, and there are also so many tools. So and Esri also divided their software using the purpose of use. So there are software for planners, there are software for environmental scientists, there are software for disaster management, something like that. Okay, so what I'm trying to say is that now Esri realized by only developing ArcGIS, it's really difficult to stay in the competition because QGIS is free, lots and lots of programmers, developers, and then GIS experts, and as well as geographer, they are contributing freely to that software, and they are making it even more robust than before. So to remain in the competition, it realized that, okay, we have to be innovative. And what's the innovation? The world is moving towards cloud. The world is moving towards internet. Everything is on internet. And people started using these Chromebooks, okay, which have only browsers, nothing else. And people like it, people prefers it. So when you can do everything online, why should you have a powerful laptop with you? And why should you have a software, and why should you burden yourself with buying more and more hard drive? And these hard disks, they can crash anytime. I mean, one of my hard disks, it crashed and I lost all of my data. I lost all of my progress of what I did during my bachelor study. It's all gone. Okay, and so instead now all the information that I could saved on the cloud, it's still there. Okay, so people now preferring clouds than these tangible storing devices. So that's how GIS is moving forward as well. You might think that after looking into Google Earth Engine, you might think that only remote sensing is moving towards cloud. It's not true. Its GIS is moving towards the cloud as well. And why am I focusing on this so much? Why am I talking about it for nearly 10 minutes or so? Because what I have found in our country that our students, they do not really focus on technology. They do not really try to explore different softwares, different platforms. And that's a very wrong move. Okay, around our country, around the world, the technology is moving very fast. If you want to stay in the same speed, you must explore different softwares. I will give you a quick example. So some of my students, they do not prefer using Teams. Okay, why? They say that, sir, it's slow, it's buggy, it takes a lot of time to load. I agree. Okay, however, it also offers some of the services which you will not find in Google Classroom, or you will not find in Google Doc. And if you do that, if you try to use them, then you are knowing another software, you are knowing another tool which is different than other tools. So in future, when you encounter multiple tools, now you can easily or freely move between different tools, and you will not have any problem in your job sector or whatever you do. Okay, so what I did, I pressed the students, you have to use it, because I'm not going to the Google Classroom. And ultimately the students started using it, and those students, those who complained earlier, many of them now like this platform. Why? Because when it comes to collaboration, it can collaborate very easily. So the same document can be edited by multiple students at the same time, and any editing block gets restricted, so other user cannot edit it. Okay, so that means what I'm writing right now, it stays intact. No one can change it while I'm writing it. But after I finish writing, if anyone wants, they can edit that document as well. So these benefits are unprecedented in other platforms. Anyway, so my message is very simple: explore different thing, explore different technology, get used to them. Okay, that will help you in future. So ArcGIS modules. ArcGIS supports legacy datasets. And what are the legacy datasets? These are the datasets that were developed and used by Esri software. The first one is the ArcInfo coverage. So just remember this for now. This is important. ArcGIS coverage is it's the software which uses topology. So it focuses on relationship rather storing the coordinates. Okay, so coverage stores relationship rather than storing coordinates. On the other hand, from ArcView, so ArcInfo, the first software, then they invented ArcView. From the second software, ArcView, they started introducing shapefiles. So the shapefiles is not topology based. What is topology? We will study them in coming lectures. So shapefile now, it's not topology based, and that's why it does not store relationship anymore. Instead it stores coordinates. Okay, so from ArcView, we started using shapefiles. Even today, we use shapefiles, and these shapefiles, they do not store in a relationship between different entities or different features. Instead, they store the coordinates of the points. So these ArcGIS module, they also have their own geodatabase. We will see them today. So what is shapefile? Shapefiles are very simple. They are non-topological. That means they do not store relationship. Okay, all they store is they store geometric location and the geometry types. So geometric location means the coordinates, and the geometric types means whether it's a point, line, or polygon. And the attribute that they have in the attribute table. Okay, so that's the attribute information of geographic feature. So that's what they include And one quick example is this. So that's your catalog. We have data, let's say USSF files. These are the folders. And now we have these shape files. I will give you a demonstration briefly. Don't worry. So these are the shape files. So we have cities, we have countries. So this is point. From this thumbnail, you can identify that these are the cities, but they are represented using points. Then we have counties, and the counties are represented using polygons. So that's the polygon symbol. And the roads are lines. So by looking at this thumbnail, you can realize that that's a line. Those are polylines. And then states are again boundaries. Okay. So along with these shape files, it can also store tables. So the tables are just like the file that on the Excel you have multiple columns and rows. However, the tables are stored in text version. Along with the text, you also have DBase. It's the acronym of database table. Okay, so the shape files. Sometimes their attributes are stored in this database table. So if you want to extract only the attributes, you can extract them or store them in a text file, in a database file, or in a CSV file. It's up to you. So each dataset is a set of 3 files. So whenever you will be creating a shape file, remember this: each shape file must need at least 3 files. I said at least. They could have 5 files, 6 files. I mean, they could be built on 5 files, 6 files, 7 files, okay, even more than that, depending on what you are doing. However, 3 files are mandatory. One is the .shp, okay, and what is .shp? .shp is the what should I say? It's the সংক্ষিপ্ত ইংরেজি কি? It's the shortened form of shape, right? So you want to write down anything with 3 letters. So if shape, you might write it SHP. That's how our brain works. So, and it contains the coordinates and the geometry of the features. Okay, this shape file contains the geometry or the coordinates of the feature shape file. And then we have SHX, okay, which contains the index information, of the shape file. So from index, we take X, and then from shape file, we take SH. Okay, so shape index, SHX, very easy to remember. So those file contains the index of feature geometry. So what's the index? So index is the which geometry comes after which geometry. Okay, so that's essentially, that's just a sequence of the geometries. Okay, they're serial numbers. And finally, the attributes that are needed in the shape file. So in the shape file, we have these maps, we have these roads, points, etc., etc. These lines, polygons, and points, etc. But then at the background, as we have seen earlier, we have attribute table, right? We need attribute table. That's the beauty of GIS. So all these attribute tables are stored in a database table, which is denoted by .dbf. So database file, okay, DBF, database file. So these 3 are essential to have any shape file. And what is the third one? Fourth one. The fourth one could be the PRJ file. Okay, .PRJ. Why do I say this fourth one is the essential one? I mean, if I extend the number of files, because PRJ is the shortened form of projection. All right, so PRJ file contains the coordinate information of this shape file. So that's very, very important. However, we'll find shape file without any coordinate information. And why does it happen? And when does it happen? It happens when you forget to copy the PRJ file of your file. Or it could happen when you didn't really create any projection, that is, you didn't assign any coordinate system to your shapefile. At that time, you will not have any PRJ file. Okay. So in the shapefile, geographic phenomena can be represented, or the features can be represented using point, polylines, and polygons. Okay, and the workspace that contains all the attributes are database table. Okay, they are very easy to transfer shapefiles. However, when you are transferring them, you must remember this list. Okay, they must have all these files, otherwise they will not work. If you share me, it happens with the first year students, I mean the first batch. When I asked them to submit me their assignment, they submitted only with the SHP file, shapefile. Okay, and it didn't work because the other supporting documents were missing. So I will stop here, okay, for now, and I will show you how these files are located on the computer, and also how the software work. So I'm going to share from other screen. Or I can just share it. Okay, so do you see my screen now? I think so, yes. Okay, so if I go back to the data table, then I have, for example, district. And do you see there is only one file named district? And district has DBF file, which is a database file. It has projection file. Okay, so PRJ, it has SHX, okay, the index file, and also shapefile, SHP. Okay, so additionally, what it does, it also has SBX and SBN files. So let's have a look. How do they look like on the software? So this is ArcGIS software. I'm going to close this. So on this ArcGIS software, I'm going to describe it very briefly. So on top we have toolbar. Sorry, menu bar. This is menu bar. Okay, and at the bottom of the menu bar we have toolbars now. So these are the different tools that we have. And these tools, they are dynamic or they are floating. What do I mean by dynamic or floating? What I mean is they can be anytime, they can be removed and replaced or rearranged. You see, if I go here, I have this moving kind of symbol. Okay, you might have to wait a little bit. Do you see that I have some with 4 arrowheads? I have my mouse pointer being turned into 4 arrowheads. Yes or no? Mouse pointer ki 4টা arrowhead হয়ে গিয়েছে?
No, sir.
হয়নি? আচ্ছা. Okay, so might be some delay. Anyway, so if you have the software, you can experiment it. Sorry. তুমি যদি এখানে নিয়ে যাও, তাহলে তোমার এখানে 4টা arrowhead এর মতো চলে আসবে. You click on it and then you can remove. You see, আমি just editor কে remove করে নিয়ে আসছি. Okay, and then you. Sorry.
একটু আগে 4টা arrowhead ছিল আর কি.
আচ্ছা. So I can remove this one, and right now let's say I want to move it somewhere. So I drag it and then I can put it here. Okay, or I can put it here on top, or I can make a new line. Okay, it's up to me. So I'm going to put it here. Okay, for now, or I can do is I can drag and close it. So close করে দিলাম, এখন তাহলে কোত্থেকে পাবো? I can right click here on empty toolbar. So right click and it will give me the list of tools those are available. So I'm clicking on editor because I closed editor. I'm editor click করলাম, editor চলে আসছে. Okay, so now I can simply drag and add it in here. So this is tool, and this is called table of contents on the left side. On the right side, we have catalog. We have search button. Okay, so that's search. I can search any tool in here. So one could be define. So yeah. So from catalog, if we go, we have Bark. In the Bark, we had district, just like my folders on the desktop, and then district. I have, yes, district shapefile. Okay, so I can add this file simply dragging it into the view. So this is called view. This window is known as view. Okay, so this window that you were seeing where the map of Bangladesh is loaded is known as view. And if you look at the bottom, I have this one is the data view, and this one is the layout view. So this layout view is used for creating any map. I want to export this image as map with legends, with north arrow, scale, title, grid line, etc., etc. I will be working in layout view. Whereas if I would like to work it, okay, something is wrong. Whereas if I want to work with the data, I have to go to the data view. So data view, I'm going to the data view, and in the data view, now if I go to catalog, I find that this is polygon, right? So now let me say wall borders, Bangladesh. So these are also these are also polygons by looking at these. And then, okay, so there are no files. So now if we look at here, you will find this is a database. Okay, this is a database. And why do I know this is a database? Because here is one symbol, this round circular shape. Okay, cylindrical shape, sorry. So that's a database, and in this database I have some data. Okay, so these are the data. This is a discharge data. So now I can find out what's going on in there. So this is what ArcGIS looks like, and that's how the shapefile looks like. Okay, so right, anyone have any question? Okay, so the next thing is the attribute table. I think we have already seen that. If you right click, open attribute table, you can find out the attribute tables. Okay, and now I can go to the properties, and from properties I can see that, okay, I can make some basic descriptive analysis. Okay, how can I do that? I go to categories. I say, all right, I have divisional code built in the attribute table. So attribute table divisional code. Let's make it something interesting. So add all values, or maybe change the color map, and then apply. So now I have the divisions color coded. So Dhaka, Chittagong, Sylhet, Rajshahi, Rangpur, Khulna, and so on. Rangpur ki division? Anyone?
Yes sir, রংপুর এখন ডিভিশন স্যার।
হ্যাঁ, তার মানে আগে আমি এই ম্যাপটা যখনকার সময় তখন তাহলে ডিভিশন ছিল না। কবে হয়েছে জানো? ময়মনসিংহ তো এখন একটা ডিভিশন, তাই না?
স্যার ময়মনসিংহ ডিভিশন হয়েছে স্যার, রংপুর এখনো হয় নাই স্যার, সরি স্যার, রংপুর হয়নি স্যার।
আচ্ছা,
ময়মনসিংহ হয়েছে স্যার।
রংপুর কি হতে যাচ্ছে?
স্যার প্রস্তাবনা শুনছিলাম স্যার।
আচ্ছা আচ্ছা, ওকে। তো সেই জন্য এটা পুরোটা রাজশাহী and then Dhaka. So Dhaka now is divided. এখানে ময়মনসিংহ একটা হয়ে গিয়েছে। Then we have Khulna, Borishal and Chittagong. কুমিল্লা কি ডিভিশন হয়েছে?
Yes sir, ময়মনসিংহ and কুমিল্লা স্যার।
Right. Yeah. So Mymensingh and Chittagong got divided into Kumilla and Chittagong as well. So this is old data. Okay, this data is from when I was this data is from Park. So this is not that old. Okay, however, it's older than Kumilla being division and Mymensingh being division. So that's how you can do some visual analysis. And by looking at this now, if you go and if you click on any file, you can find that, okay, so Tangail, it's in Dhaka, and Joshua, it's in Khulna. And for this, all this exploratory descriptive analysis you can make, okay, and then you can now do further analysis with this data. So anyway, I'm going to stop sharing from the software and let's go back to the slide. So the shape files, they do not have any relationship database management system because the data structure is very simple. Okay, however, the data structure, it might get complex with after adding so many things. For example, once I created one road network data for Bangladesh and it got really complicated after adding so many roads and secondary roads. Okay, so it could happen. The data structure could get to some extent very complex, not very complex, but complex. Okay, however, if we have just seen the map of Bangladesh and the data structure is very simple. Okay, and most of the time the vector data, the shape files, they have simple data structure and there is no topology. So since there is no topology, there is no relationship. Okay, that means there are duplication of lines. And what do I mean by duplication of lines? In topology, these two are shape files. These two are two different polygons, right? And in topology, what they have is they have one common boundary. So that means they have only one single line for separation of the boundary. Whereas in shapefile, to identify this boundary, okay, to have these two polygons, you have two lines at this point. Maybe I think it's better if I show you. তোমরা কি আমার বাংলাদেশের ম্যাপ দেখতে পাচ্ছ? দেখতে পাচ্ছ, right?
জি স্যার।
So if I zoom in, now I'm going to editor. Okay, so right click and then edit feature, start editing. You see we have two shapefile. So one shapefile belongs to, what's that, Shirazganj, and the next one is Tangail. So Shirazganj and Tangail. Tangail. Now, if I want to click, so that's my polygon of Sirajganj, right? And this is my polygon of Tangail. Let me zoom out a little bit so that you can see the entire thing. So that's Sirajganj and Tangail, and they have this common boundary. তাই না? তাদের মাঝখানে এটা একটা কমন বাউন্ডারি আছে। ওকে, এখন এই কমন বাউন্ডারিতে কয়টা লাইন আছে? What do you think? Let's see. They have two lines. Okay, one line is part of this polygon and another line is part of this polygon, and these lines, they do not have any gap. Okay, তাদের ভিতরে কোনো গ্যাপ নাই, এমন ভাবে তারা তৈরি, তাদের ভিতরে কোনো গ্যাপ নাই। আমি ম্যাক্সিমাম আমি এখানে তোমাদেরকে দেখাই বরঞ্চ, তাহলে তোমরা দেখতে পাবে। দেখো edit vertices. Okay, so I click edit vertices and these are the vertices of Tangail shapefile. Okay, I'll show you how is it Tangail shapefile. You see now the Tangail shapefile got all the vertices mapped out. Okay, so this is the node which is as red. Okay, so this is the node, it's in red color, so that was the beginning line, you see, and all these things are vertices. So yesterday Farah, I think, was asking that how many nodes that the shapefile, sorry, a polygon could have, and you see there is one node. Okay, so now if I drag some of the vertices, let me select all these and drag them out here, and you see now they have a gap. Okay, so now there is a gap. Let me click this one. Okay, let me click this one and let me click edit vertices. So now the node of this polygon is here in red, and all my vertices are mapped out. And if I zoom here, you see it has another line. So I can select all these vertices and I can drag them here, out here. Okay, and now I say that okay, so I'm done. Okay, I'm done. So should I going to save it? Obviously not. I'm not going to save the progress. So let me simply clear out all the selections that I made. So if I save it right now, it will look like this. Okay, it will look like this because I created these two common boundaries, but then I'm not going to save it. Okay, so I mean, I'm not going to save the progress or the changes that I made. So what I'm going to do is I'm going to say stop editing. Do you want to save your edits? No. So now, if you look, that's the proof that in shapefile, what they have is they have two boundaries that is shared by two different polygons. Okay, তোমরা কি আমার স্লাইড দেখতে পাচ্ছ এখন?
জি স্যার।
ওকে, সো এটাই এখানে বলা হচ্ছে যে যখন টপোলজি থাকবে না, তখন আমি এটা বাংলায় বলি তাহলে তোমাদের বুঝতে সুবিধা হবে। যখন টপোলজি থাকবে না, মানে শেপ ফাইল ইউজ করবে, তখন তোমার দুটো পলিগন, প্রত্যেকটা পলিগনের এক একটা করে বাউন্ডারি থাকে। ওকে, সো দ্যাট মিনস যখন তারা একটা কমন বাউন্ডারি শেয়ার করবে, তখন তারা কি করবে, তারা তাদের প্রত্যেকের পলিগন থেকেই আমাদের একটা করে ওই শেয়ার্ড বাউন্ডারি যে অংশ থাকবে সেখানে একটা করে লাইন থাকবে। সো উই হ্যাভ টু লাইনস জাস্ট লাইক উই হ্যাভ জাস্ট সিন। বাট ইফ ইটস টপোলজি, ওকে, যেটা হচ্ছে রিলেশনশিপের উপরে ডিপেন্ড করে হয়, at that time you will have only one single boundary because this boundary belongs to this polygon. Okay, also at the same time this boundary belongs to this polygon, and in this relationship it doesn't what it does is it says, say this polygon is A and this is B. It will say that this is the arc, and or this is a line, and on this arc, on the left hand you have polygon A, on the right hand you have polygon B. Okay, এখানে যদি দুটো আর্ক থাকে বা দুটো লাইন থাকে, সেক্ষেত্রে কিন্তু তুমি আর বলতে পারছো না যে এটা একটা স্পেসিফিক লাইন, because you have two. Okay, so that is the difference. আমি মনে হয় ভালো করে বোঝাতে পারলাম না জিনিসটা। If you have question, do let me know. আমরা টপোলজি পড়ার সময় এগুলো এমনিতে অবশ্য চলে আসবে। Just know this, যে টপোলজির ক্ষেত্রে এখানে শুধু একটা লাইন থাকে instead of two. ওকে, এবং এই একটা লাইন হচ্ছে দুটো পলিগনই এই একটা লাইনকে তারা শেয়ার করে। ফর এক্সাম্পল, তুমি যখন তোমার নেইবারের সাথে বিল্ডিং তৈরি করো, বাউন্ডারি বিল্ডিং, তখন কিন্তু একজনই বাউন্ডারি বানায়। এটা হয় তুমি বানাও অথবা তোমার নেইবার বানায়, দুজনেই কিন্তু বাউন্ডারি ওয়াল দাও না, তাই তো? সো দ্যাটস আ টপোলজি। ওকে, এখন আমি ওই বাউন্ডারি ওয়ালের উপর দিয়ে হেঁটে হেঁটে যাচ্ছি আর বলছি ডান পাশে আমার বাসা, বাম পাশে তোমার বাসা। আমার হাতের ডানে আমাদের বাসা আর আমার হাতের বামে তোমাদের বাসা। আমি এভাবে তখন মানে সেটাকে এক্সপ্লেইন করছি, and I am walking on the wall, ঠিক আছে, বা ওয়ালের উপরে বসে আছি বা হেঁটে যাচ্ছি, এক সাইড থেকে আরেক সাইডে হেঁটে যাচ্ছি। সো এটাই হচ্ছে টপোলজি। টপোলজি এই কাজটা করে। ওকে, তুমি যখন একটা আর্ক থেকে একটা ভার্টেক্স থেকে আরেকটা ভার্টেক্সে যাবা, ওই ডিরেকশনটা তোমার থাকবে এবং তুমি বলবে আমার হাতের বাম পাশে এটা আছে, ডান পাশে এটা আছে, সম্পর্ক। ওকে, এখন শেপ ফাইল কোনো টপোলজি কন্টেইন করে না, সেই কারণে তার একটা শেয়ার্ড বাউন্ডারি থাকে না। যেভাবে আমি মাত্র বললাম যে তুমি এবং তোমার নেইবার একটা বাউন্ডারি শেয়ার করো। ওকে, একটা ওয়াল তোমরা শেয়ার করো, যে কোনো একজন বানাই এটা। সো তখন হয় কি, তখন ডুপ্লিকেশন অফ লাইন হয়। তখন করে কি, ধরো তুমিও একটা ওয়াল দিলা, এখন তোমার নেইবারও একটা ওয়াল দিল। তুমি বললা এটা আমার বাউন্ডারি ওয়াল, তোমার নেইবার বললে এটা আমার বাউন্ডারি ওয়াল, বা দুজনের ওয়ালের মাঝখানে কিন্তু এখন কোনো গ্যাপ নাই। একেবারে তোমরা এই যে কংক্রিট ঢেলে পুরোটাকে একেবারে গ্যাপ বিহীন করে ফেলে দিয়েছো। ওকে, যদি গ্যাপ থাকে তাহলে এটা এরর। মাঝখানে খালি জায়গা আছে, এই খালি জায়গাটা এখন কার? ওকে, সেটা 1 ইঞ্চি হোক 2 ইঞ্চি হোক, এই খালি জায়গাটা কার? এটা কারো না তখন। ওকে, অনেকটা আমাদের ওই যে এটাকে কি বলে জানি, বর্ডারে যেগুলো থাকে ছিটমহল। ওকে, ছিটমহলের মতো। So now in shapefile behaves in this way. In shapefile যখন কোনো কিছুর বাউন্ডারি থাকে, পলিগন থাকে, দুটো পলিগন থাকলে তারা দুজনেই ওই লাইন, নিজস্ব লাইনটাকে দিয়ে দেয়, বলে দিস ইজ মাই বাউন্ডারি, দ্যাটস ইউর বাউন্ডারি। এবং এটা রিয়েল লাইফ একটা এক্সাম্পল আছে। ধরো ঢাকায় অনেক বিল্ডিং তৈরি হয়, যে বিল্ডিং গুলা হচ্ছে একটার সাথে আরেকটা লাগানো। ওকে, একটার সাথে আরেকটার ওয়াল একেবারে লাগানো। সো তখন কি, ধরো কথার কথা, আমাদের এখানে আমি একটা বিল্ডিং তুলে রেখে দিয়েছি, আমার এলাকায় আমি একেবারে আমার বাউন্ডারির সাথে লাগিয়ে একটা বিল্ডিং তুলেছি। এখন তুমি এসে ওই বাউন্ডারির সাথে লাগিয়ে আরেকটা বিল্ডিং তুলতে চাচ্ছ। এখন তুমি কি বলবা যে স্যার তো ওই জায়গায় অলরেডি একটা ওয়াল দিয়ে দিয়েছে, তাহলে আমার বিল্ডিং এর জন্য তো আর কোনো ওয়াল লাগবে না, ওই ওয়ালটাই আমি ইউজ করে ফেলবো আমার বিল্ডিং এর ওয়াল হিসেবে? সেটা কিন্তু লোকজন করে না। তারা করে কি, তাদের বিল্ডিং এর জন্য তার আরেকটা ওয়াল বানায়, বাট ওই ওয়ালটা থাকে হচ্ছে একদম, তুমি তখন করবে কি, আমার ওয়ালের সাথে লাগিয়ে নতুন করে তোমার বিল্ডিং এর আরেকটা ওয়াল তুলে ফেলবা। ওকে, সো দ্যাটস শেপ ফাইল। ওকে, শেপ ফাইলের ক্ষেত্রে তখন তুমি বলছো এটা আমার ওয়াল, আমি বলছি এটা আমার ওয়াল, বাট আমাদের দুজনের ওয়ালের মাঝখানে কোনো গ্যাপ নাই, 1 ইঞ্চিও গ্যাপ নাই, 1 সেন্টিমিটারও গ্যাপ নাই। এটা দুটোর ওয়াল একেবারে একে অপরের সাথে লাগানো। Okay, so that's what it says. Since it has no topology, it has duplication of lines, okay, at the same location, and this duplication of lines could lead to some error, and these errors are known as slivers. Okay, so this is very important. These duplication of lines could lead to some error. These are known as slivers. And what are slivers? Slivers are these. তোমার এখানে একটা, ওই যে বললাম যে ভুলে, রাজমিস্ত্রির ভুলে 1 ইঞ্চি গ্যাপ পড়ে গিয়েছে, এখন এটা কারো নয়, ছিটমহলের মতো হয়ে গেল। ওকে, সো ওই কি বলে, সো এই ভুলের কারণে ওভারলে যখন করা হবে তখন এইভাবে মিসম্যাচ যদি হয়, দেন দেয়ার কুড বি সাম গ্যাপ ইন বিটুইন, সো দিস আর নোন অ্যাজ স্লিভার্স। ওকে, সো দিস আর নোন অ্যাজ স্লিভার। দেখো এখানে একটা পলিগন ছিল, এখানে একটা পলিগন ছিল, আমি তাদেরকে ওভারলে করেছি, তারা ওভারলে হয়েছে, একে অপরের উপরে বসেছে, বাট দেন দে হ্যাভ সাম গ্যাপ বিটুইন দেম, সো দিস ইজ an error. Now this error has to be fixed if you want to do further analysis. Okay, and it's one of the common issue in GIS that we have. I mean, আমি যখন কাজ করেছি আমার হয়েছে, দিন রাত বসে বসে আমাকে এগুলো ঠিক করতে হয়েছে। So the geodatabase model, we have seen the geodatabase with this shape just a moment ago. Okay, so these parts, we have multiple types of geodatabase. We have personal geodatabase, which are stored in MSA access and known as MDB. একটু আগে আমরা যেটা দেখেছি সেটা হচ্ছে personal geodatabase. They can store till 2 gigabytes. They cannot exceed more than 2 gigabytes. File geodatabase, they can have a maximum size of 1 terabyte. Okay, and can be increased to 256 terabytes for larger dataset, for example, raster. Okay, and they are controlled by configuration keyword. And enterprise geodatabase are the geodatabase that is being used by BUP, that is being used by Google or any other companies or institution. Their personal geodatabase, their personal databases. If that personal databases now have the properties of GIS or geographic information, now we can say that that's an enterprise geodatabase. However, enterprise geodatabases are being also sold and organized by companies like Esri, and it has no size limitations. তুমি হার্ড ডিস্ক এনে লাগাই দিবা, তোমার সাইজ ইনক্রিজ হবে, নতুন হার্ড ডিস্ক এনে লাগাই দিবা, সাইজ ইনক্রিজ হবে। Okay, so in a moment I will show you personal geodatabase and file geodatabase. Okay, so that's the geodatabase model. Have a look into this. So this is feature dataset. You have multiple features. You have, let's say you have point, line, and polygons, and you group them. Okay, these are the feature classes. You group them together, and you get feature dataset. In this dataset, you have multiple data. Okay, for example, point data, polyline data, polygon data. Okay, so then we have topology, which is the relationship. This is geometric network. In your 4102, you will have geometric network. I will give you the geometric network and you will be working on that. If not, then in your masters. So feature class, these feature classes are again broken down into 2 types. One is the table, which is an attribute table. It's stored in DBF file, and the relationship class. Okay, and also the geodatabase can manage raster data. So this is the raster catalog, which is the equivalent to the feature dataset. And these raster catalogs, they contain these raster datasets. Okay, so one thing to remember, this individual raster is known as raster dataset, whereas multiple feature classes together makes one feature dataset. Okay, so inside a feature dataset, you have multiple feature classes. Each feature class denotes to one single layer. Okay, whereas in raster dataset, it's just a single raster layer. Okay, and if you put multiple raster datasets together, you have raster catalog now. Okay, so geodatabase model, have a quick look into it. I'm not going to explain it, read this. And this is just to show you how do they look like at the background. So that's their relationship. You do not have to memorize all these things or read them, just have a quick look. That's how they are structured, databases. Okay, so this is MDB, that's a personal database. Okay, I just said the personal database here, geodatabase. So they are stored in MS Access. Remember, okay, Microsoft Access, they are written in Microsoft Access. So that's why it's also can be identified using MDB. Maybe you can memorize it by saying that it's a Microsoft database, so MDB. So this is feature dataset, okay, and then you will find the feature classes here. Anyway, so feature dataset, it's a collection of related feature classes, and they share a common geographic coordinate, sorry, not geographic, but coordinate system, okay. So they remember they must share, all the feature classes must share a common coordinate system, otherwise you cannot put them into the same data set. And also they are also within a common spatial extent. Feature classes, they are the collection of common features. For example, what are the features? For example, points. So if it's a point class, you can add only point in there, you cannot add polyline, okay. And that's why in this symbol, for each layer, you have this symbol. So that means this layer contains only points, not polylines, not polygons, okay. Whereas in raster, in a single raster, you can have cells representing points, you could have cells representing lines, you could have cells clustered together and forming a polygon, I mean area, okay. So if it's a polygon, it can contain only polygons. The same way, if it's a line, it can contain only line. If it's annotation, so annotation is the text that you add sort of dynamically, you add them with the polygons or other feature classes, then these are known as annotation, okay. It's quite similar to embedding. অনেক সময় আমরা embed করি না? Those who do a little bit of programming, they know that, I mean HTML, not programming. So you know that sometimes you embed other things from, for example, sometimes in someone's website, you will find that they added one YouTube video. If you can play it on their website, or you can click on the YouTube logo at the video player, and it will take you to the YouTube, and you can watch it on YouTube. So what they did was, at the back end, in the HTML code, they embedded that code of that video in their HTML code of their website. So now the YouTube video is being played on their website. Same is for maps. Sometimes what they do is they embed the code of Google Map into their website, and you can find out that, okay, you can access that Google Map on their website as well. So similarly, same thing, annotation. Okay, so each class can contain only one type of feature, be that point, line, polygon, or annotation. And they could have some common set of attribute columns, and etc. Have a look. So feature data, they could have two different types. One could be coverage, which is based on topology. Another one could be based on shapefiles. So as I said, topology deals with the relationship, shapefiles stores the coordinate information, okay. And both use a georelational data model. Okay, and the vector data is stored in they're stored in binary files, and then we have unique identifiers which link all the geographic features with the attribute table. So now the software knows that when I have a polygon, when I click on it, the software knows where this polygon belongs to, and what is the name of this area, or what is the population of this polygon, etc., because all this information was stored in attribute table, and with attribute table information, the polygon is connected. Okay, that's what it says. There is unique identifier which is linking the feature and the attributes stored in the other files, because you have already seen the attributes are stored in dbf file, and all the files indexes were stored in SHX file. So database management system feature model, it's a geodatabase data model So feature stores in rows in a relational geodatabase model, and row contains spatial and attribute information. So to understand this, you have to have some idea on geodatabase. You do not need this information right now. However, I will quickly explain. It's sort of like Excel. Okay, it's sort of like Excel. In Excel, what do I have? Let's say when your results get published, you have your names on the rows and the results on the columns, right? So you have, for example, the subject 220, 3201, 3203, 3205, and 3207, and so on. And you have your names. Okay, so each of you, imagine yourself, you are a feature. Okay, so that's what it says. The feature is stored in rows. So imagine you, role 1 is feature number 1. So all his or her information are located in that row. And these categories or the properties are divided or based on the column values. So for example, for you, the class 1 or 3201, you got 90% marks. In 3203, you got 20% marks. In 3205, you got 50% marks. Okay, so and then so student number 1, student number 2, student number 3, all of them are located in the rows. So that's what it says. The rows contains spatial and attribute information. So for all these features, the features are stored in the rows, and each row throughout the columns, we have now the spatial and the attribute informations are stored. I will show that to you in a minute. Let me just finish this slide. So point feature shapefile. There could be two types. How many slides do I have? I think I have only 2 left. No, I have many. So I'm going to stop it here. We will start it from this slide from next week. Let me quickly show you how does it look like, the database. And we will finish it for today. So let me go back to the database. So we have data. No, was I? Oh, right. So we have data, and we have, for example, rivers. And you see this MDB. Okay, so MDB is a personal geodatabase. And if I click open, it's going to open it in Access. So now you see I have all the data stored in MDB, which is a personal geodatabase. I have the station IDs and I have their information. Okay, so that's how database look like. Now let me show you how the other database look like. Let me create one folder here. So I'm going to create in data, I'm going to create a new folder, which is test. And in this folder, I'm going to create one file geodatabase, right? So file geodatabase, it can store up to 1 terabytes of data. So new file geodatabase. So test, it's GDB geodatabase. I'm going to create one new personal database. So personal geodatabase MDB. Okay. Leave it just like new personal geodatabase or name it as test as well. Okay. Okay, so I have two databases now. So what I want to do right now, I have district, and I have this district shapefile. I want to copy, and then I want to paste it here. Can I paste? No, no. Then I have to import it. So import feature class single. I'm going to import one single feature class. So I'm going to select my file district. So that's file test MDB, and output feature name would be district as well. So what do I want to map? I want to map all of them. Okay. All right. Close. So this one has been imported into here, district. Okay. So now I'm to import it here. Feature class single, district, and then district again. Okay, let's make it 2. District 2. Okay. So now I have, from this catalog, I have 2 databases, and these 2 databases have one shapefile in each district 2, right? তোমরা সবাই ফলো করতে পারছো? I hope follow করতে পারছো. So now on here on top on the toolbar, I have full extent. I'm clicking on full extent, and it's going back to the full extent. Okay, আমার যা কিছু আছে সবকিছু এখন এখানে দেখতে পাচ্ছি. So this is how the database look like, right? So I can see my feature class. I can see my feature class, which is a polygon. Now let me see how do they look like in the folder. So a few moments ago, we have seen district. The shapefile looks like this, right? We have these DBF files, we have projection files, we have the shape SHP files and others. Now, let me go back to data and go into test. Yes, so now I have one geodatabase, file geodatabase, and one personal geodatabase. Okay, let me try to look into the file geodatabase. We can store up to 1 terabyte. What do you understand? You understand nothing, right? It doesn't make any sense. I have this is test GDB. In my test GDB, I have one district 2, and there is nothing written as district 2. Because all the information, they are stored in the geodatabase. Okay, so in database, you will not understand anything. However, I can share this database. I can send this database to you. And if you open this database in your ArcMap, at this geodatabase, in your ArcMap, you will find all the feature classes. If you access this geodatabase from catalog, you will have access to all these feature class or feature classes if I have multiple. However, if you look into the geodatabase directly in your folder, you will find these sorts of information which will not make any sense. Now, let's try to have a look into the personal geodatabase. Earlier, in the personal geodatabase, we had, okay, so it cannot be opened. Let me close these, exit, no. Okay, so now, you see, in my personal geodatabase of the text MDB, I have all these tables listed. So first one is the district. Let me click, see what happens. Yes, so this is the district. You see the object ID, then let me make it larger, long binary data, then record ID, then area, district code. So this one belongs to the how This, I think this one, it belongs to the what do you call it, attribute table. Okay, so the district containing the attribute table, because this is how it looks like. Now the shape index, you see, the shape index contains their extent. So that's the indexed object. Okay, the number of the object. So these are the object ID. Okay, 1, 2, 3, 4, 5, 6. So these are the same object ID being used to identify the object, and this is the minimum X, minimum Y, maximum X, maximum Y. So their extent, okay, their extent of the each polygon. And then column info. So in my column info, I have all these field names. So field names are stored in a separate geodatabase. I mean, in a separate database. Then I have geom columns. Okay, so I have, see, all these district and GDB items. So that's the table name, which is this one, and this is the items that it has. And also, similarly, I can now examine all these things. Okay, can you examine all these things? So there are, now you see there are multiple things at the background that works together to form the view that we have. Okay, when you look into the database, the structure of the database, then you might have access to all this information which are acting at the background to form all these representations. Anyone have any question? Okay, in that case, I'm going to stop recording.